Today, the agenda will include a little bit about myself, objectives, have a high-level core tools overview, APQP and quality linkage, PPAP elements. That's where we're going to define where FMEA or failure mode and effects analysis need is coming from. High-level overview on the FMEA and its applications. Then we'll get into the Process FMEA part of it. Again, overview, talk about the methodology we're going to follow, the guidelines, and a couple of examples. I'm known as the subject matter expert, not only in quality, but also in productivity improvement, problem solving, a bunch of different engineering fields, international standards. I did work for a tier 1 suppliers, OEM, FCA. Most currently, actually, I'm working for, and I used to work for PMC. Most currently, I'm working for aerospace industry, a company called Boeing. So again, lots of experience around, again, quality, advanced product, quality planning, and other fields. I do have a PhD from Purdue University. So having said that, the objective here is that we want to define what FMEA is and why it is needed, and more specifically, the process failure mode and effects analysis. At the bottom of this slide, as it's highlighting, the failure mode and effects analysis is a part of the core tools that AIAG actually publishes. Quality core tools, these are considered to be quality core tools, the APQP, PPAP, FMEA, MSA, and SPC. And as it's highlighted here, we're going to focus on FMEA. The PPAP elements in automotive, again, as per the AIAG manual, there are 18 PPAP element requirements, and PPAP stands for Production Part Approval Process, and Process Failure Mode and Effects Analysis is the 6th requirement of the PPAP. So what's the advanced product quality and the quality linkage? At the end of the day, the ultimate goal of APQP is to satisfy the customer. And in order for us to do that, we really need to apply APQP in which it will assure us robust designs, producible products, capable processes, timely production, and of course, on-time delivery. And if you think about the PPAP elements that we mentioned earlier, the 18 requirements, those will be the evidences of us meeting the requirements and satisfying our customers. So the little high-level overview on the I apologize. Let me put this on a presentation mode. The FMEA, very high-level overview. There will be a few slides. I wanted to point out what FMEA is before I talk about the process FMEA. FMEA development, either design or process, uses a common approach to address the potential product or process failure to meet the expectation. Potential consequences, potential causes of the failure mode, application of current controls, level of risk, and risk reduction. So before FMEA document is started, the team, when I say team, it's critical that in this environment we have to have a cross-functional team that consists of, at a minimum, there's a core team and then there is the larger scale team that supports the effort. But the core team must include the design engineer, the manufacturing engineer, quality, operations. Of course, it will include the materials, logistics, and all that too, but these are the core team members that will have to be driving this effort. So the team must define the scope of the project and collect the existing information which is necessary for an effective and efficient FEMA development process. FMEA, or the failure mode effects analysis format, may vary based on the needs of organization and customer requirements. The format at least should address the function, requirements, and deliverables, failure modes when functional requirements are not met, effects and the consequences of the failure mode, potential causes of the failure modes, actions and controls to address the causes of the failure mode, and finally, actions to prevent the recurrence of the failure mode. So there are different types of FMEAs. It starts with the system FMEA, subsystem, and component. The system FMEA is made up of various systems where the focus is to address all interfaces and the interactions among systems, subsystems, the environment, and the customer. And I include a couple of examples here that, for example, in a vehicle manufacturing, a chassis system, the powertrain system, and interior system. On the other hand, the subsystem FMEA is a subset of a system FMEA where the focus is to address all interfaces and interactions among the subsystem components and the interactions with other subsystems or the systems. And an example here I included is the front suspension subsystem, which is a subset of the chassis system that I listed here as part of the system FMEA. Finally, the component FMEA, which is a subset of a subsystem FMEA. And a good example of that would be the brake pad, which is a component of the brake assembly that is a subsystem of the chassis system. So again, we also have, as I mentioned earlier, the team that consists of cross-functional effort. When we do the FMEA, we need to consider 4 major customers, and all need to be taken into account when we complete the analysis. One of them is the end user. The person or the organization that will utilize the product needs to be considered. The OEM assembly and manufacturing centers, in other words, we call them the plants. The OEM locations where the manufacturing operations and the vehicle assembly take place. Well, again, it could be different as well. The next one is the supply chain manufacturing. This is where the supplier location, manufacturing, fabrication, or assembling of production materials or parts take place. And finally, regulators, government agencies that define requirements and monitor compliance to safety and environmental specifications. There is also international standard regulations that we may have to comply with. So not only the government agencies, but also the international, like third-party registrars, could actually be treated as the regulators. So in FMEA, the risk can be identified in 3 ways. Starts with severity, which is an assessment of the level of impact of a failure on the customer. Then the occurrence, which is how often the cause of a failure may occur. And finally, the detection, which is an assessment of how well the product or the process controls detect the cause of the failure or the failure mode. Now, in addition to that, the FMEA or even overall APQP is a top-driven initiative, and management actually owns the process. It's owned the process by selecting the resources, applying resources to those selected areas, adapting effective risk management process, measuring the process timing, conducting ongoing reviews, eliminating roadblocks, and finally incorporating the lessons learned into their existing product lines. So where can we apply FMEA? When we have new designs, new technology, new process, product design changes, process design changes. If you're moving into a new environment, new location, new application, those are some of the the areas where we can apply FMEA. The Process FMEA supports manufacturing process development in reducing the risk of failures by identifying and evaluating the process requirements, identifying and evaluating the potential process-related failure modes, the effects of the potential failures on the process and customers, identifying the potential manufacturing or assembly process causes, identifying process variables on which to focus process controls for occurrence, reduction, or increased detection of the failure conditions. Finally, enabling the establishment of a priority systems for preventive corrective action and controls. The PFMEA is a living document, just similar to the DFMEA that we talked about last time, and it should be initiated before or at the feasibility stage. Be initiated prior to tooling for production. Taking into account all manufacturing operations from individual components to assemblies. Include all processes within the plant that can impact the manufacturing and assembly operations, such as shipping, receiving, transporting of materials, storage, conveyors, or labeling. Now, what's the methodology that we use for the FMEA? What I did here is I put the methodology in a SIPOC environment. For those who are not familiar with SIPOC, it stands for Supplier Input, Process, Output, and Customer. It's a great pictorial tool that we use to kind of visualize what makes up the process. So when I say supplier here, that means the input, the resource of the inputs. So they are design engineers, manufacturing engineers, quality engineers at a minimum. So what they do is they provide all these inputs that are process flow diagram, quality performance data, PFMEA, DFMEA, KCs. Well, KC stands for the key characteristics or the critical items, and control plan. Now, again, these are the input for a PFMEA, but of course, these are like the PFMEA for a similar part or the same part or component for the legacy program can be used as an input to develop the current PFMEA. Same thing again. So anything that are in the input here either are initial, the first draft of the documents or the risk assessment, or where you can bring the similar parts, product families, PFMEAs and DFMEAs, and again, use those as an input to develop the PFMEA. So all these go through a process with a cross-functional team, developing potential failures, the effects, the severity, causes, preventive methods, the frequency detection and RPNs, then the correct recommended actions, and based on that, we recalculate the RPN. So that's the methodology that we use. At the end, we have, as an output, we have an approved PFMEA. Again, that PFMEA is developed by internal team, and it's usually, if it's required. There are cases where it's not approved by the customer. Sometimes some customers may say, okay, just provide me the evidence that you did the risk assessment, and they share with me or review your PFMEA with me, but they don't have to just approve it. They just review it and give okay. But some customers, they have to. There is an approval process where they review it and make sure that they sign off on it before you can even move to the next step. And then finally, the customer, right? And depends on if it's internal or external customer. So the template that we use in the PFMEA, as you can see here, there's a title block. I didn't want to spend a lot of time on that one because the title block usually includes what part number, what's the revision level, what's the team, and the date, origination date, revision date, and again, very generic information, but it's required that you actually complete it fully. But I wanted to focus on the template itself. As you can see here, the template starts with the process step, process description, and the requirement for each of those description process step. Then what we do is, and by the way we develop the PFMEA, we go always from left to right. So in that case, so for each of the step, we define the potential failure mode, the effect of that failure mode on a customer, right? One of the 4 customers or 4 customers we're going to have to consider, depending on the situation. Then we need to assess the severity or the effects of the failure mode on the customer. That will define the severity of the ranking, and the severity is from 1 to 10. The classification here is that if any of that characteristics or requirement or process step is treated as either key characteristic or critical item, if it's a safety related or if it's a dimensionally critical feature, we just put KC or CI in this column. Then we look at the causes or cause of the failure mode. So you may have multiple causes for each of these failure modes. The current process prevention controls. So this one here, we look at our process to see if we have any prevention controls that will prevent that cause from happening. And based on that, we're going to have to rank. The OCC stands for occurrence. Again, it's also rated from 1 to 10. 1 means it will never happen, almost. And 10 means it is going to happen, like the percent is up to 12.5% or something like that. So we have tables for that, so I'll share them with you a little bit later on. So from there, not only the prevention controls, we also look at the detection controls. What are some of the detection controls? And based on the capability of the detections, we also have a rating for detection, which is from 1 to 10 again. And the next one is the severity time occurrence. That's called criticality. And for the scope of this webinar, we're not going to talk about that, but we will more focus on the RPN. So risk product number, or sorry, risk priority number. It's an arbitrary number that actually quantifies the risk level for each of those causes in the failure modes. So, and that's made of, it's actually the product of severity times occurrence, occurrence times detection. So now, once we have determined the RPNs for every step of the way in our processes, then we rank them based on the RPNs, from high to low. And usually we start to focus on the top 10 or 20% and try to mitigate those high risk causes or the failure modes first. And the way we do that is that through either brainstorming or some kind of analysis, the cross-functional team comes up with recommended actions. And that recommended action or actions are going to be assigned to a person. That's where the responsibility, a name is required to be put in here, and then with some targeted date. So then when the person actually leads the initiative or this action, when it's done, that person will have to define exactly what was done, because what's being recommended not necessarily is what's done. There may be some differences. So this person has to make sure that what's taking place is documented and the effective date, so the completion of that recommended action. Then the team has to reevaluate or re-rate the severity, occurrence, and detection based on the corrective action put in place and the action result RPN. So the RPN is recalculated based on, again, this recalculated ratings. So that point, now you can see the RPN before and RPN after improvement, and the gap between the two will determine the risk assessment improvement the team had accomplished. So from here, so I provided some additional information about what each column is about. The process operation step, again, is the identification number of the operation. And one of the reasons why we're doing that is because the PFMEA is actually, there are two other documents or tools that are linked. It starts with the PFD, Process Flow Diagram, and then the process steps and the descriptions are coming from PFD. So it's best that we define those steps so we can match the PFD and PFMEA. And also after this, there's a control plan where, again, we're taking the process step and description and the requirements from PFMEA and move them into the control plan. And we'll talk about that later in one of the future webinars. So in this case, the next step is, again, describes the purpose and the intent of the process step. Requirements, list the requirements of each process step. If there are several requirements, then separate them into individual rows. It's important to understand this because the way that we're going to have to branch out your process steps, the first time around, it's going to start with the requirement. If you have multiple requirements, that means you may have multiple potential failure modes, and each has to be treated separately. And because of that, we actually add a separate row for each of the requirements. The next one then is the potential failure modes. So we're going to have to list where the process could fail to meet the requirement for each requirement. In this case, we're going to have to consider the 5 types of failure modes, either full failure, partial, intermittent failure, degraded failure, unintentional failure. There may be many failure modes for any one requirement. If there are several failure modes, then separate them into individual rows again. So that's another another point where we can actually branch out for the PFMEA is that if there's a potential more than one failure mode, you have to use a separate row for that. The next one is the effects. You have to list the effects for each potential failure mode as experienced by the customer. The customers may be internal, external. All the effects now, in this case, are listed in the same cell. The key point is that as a team, identify what is the worst effect for ranking. So unlike the requirements and the potential failure mode, we put all the effects in one, and we take the worst case to be used for the ranking on this severity. The classification, I talked about it earlier, KC and the CI. Potential causes of the failure modes. Again, you have to list the causes for each potential failure mode. If there are multiple causes, and this is the third reason why you need to branch out the PFMEA, is that you may have multiple causes that are potential causes that are being considered. So you have to, again, separate the step into different rows to attack them individually. Current process prevention controls. Again, here we're listing all current process methods used to prevent the cause of the failure modes. For example, mistake proofing, error proofing, whatever, again, can be used to prevent it from happening. The next one is the detection. And we have to list all current process methods used to identify the cause of the failure. And the recommended actions, as I pointed out, we have to list actions from the cross-functional team to reduce the RPN. Now, RPN, as I mentioned, is a product of severity, occurrence, and detection. The RPN can be ranged from 1 to 1,000, just because severity can be from 1 to 10, occurrence 1 to 10, and detection 1 to 10. So if a failure mode or cause of a failure mode has a severity of 10, occurrence of 10, and detection of 10, that means it's 1,000. So that's the maximum number it can actually be. And this is, again, as I mentioned before, this is the way to quantify the risk with each of the failure modes or the causes of the failure modes. These are the tables that I mentioned earlier. The guide that we have, the guide, and these are coming from the AIAG PFMEA manual, FMEA manual. As you can see here, the effects, the hazardous without warning, the criteria, again, for severity of effect on the product. Potential failure mode affects safe vehicle operation and or involves non-compliance with regulations without warning. The criteria here for the manufacturing assembly is that may endanger operator, machine or assembly without warning. So think about you're working around a robot and robot comes and hits you. That's 10. But if the robot, you're working nearby a robot, but then the robot has a, let's say, a sound alarm or something, when it gets close to a human, it starts making sound alarm. It still moves, but to warn people, see, at that point, it's a 9 because there is a warning that, that is being built in within the process. So that's the worst case, right? And then the best case would be maybe very minor or none would be slight inconvenience to operation or operator or no effect at all. So then the occurrence table, as I was mentioning before, the 10 through 1, 10 means very high persistent failures. In this case, actually, they're greater than 100 per 1,000 pieces or 50 per 1,000 pieces for the ranking, occurrence ranking of 9. The 1 would be like a failure is unlikely. The percent is, if it's like a 0.01 per 1,000 pieces. The detection rating, the detection is a little bit more complicated because we may have human detecting some of the causes of the failures, or the human with some gauges, automatic gauges, or full automatic gauges. So depending on the inspection types, you can have a different detection capability. So again, 10 being the worst, that means it's almost impossible. So in other words, you're totally depending on a person, and you're not even checking for a cause or failure mode. And the best one would be control certain to detect, which means discrepant part cannot be made because item has been error-proofed. So a couple of examples here I provided. This has to do with this is a surface mount technology. It says here the reflow oven, bottom and top side. There's a thermal reflow, lead-free, solder only. It says, what's the potential failure mode? Fracture solder joint. So what would be the effect of that? Functional failure or field failure. Joint does not meet the IPC standard spec. The severity to team has identified as a 6. There's no specific or there's no case or CI. Potential cause of this is that incorrect oven profile or machine setup. Then the occurrence, they rated it as 1. That means apparently it almost never happens. The current process, the prevention controls, they said it's work instructions. That means they created work instruction, trained the people on it. There's a setup sheets that they have to use for each time they set up the operation. There's a profile, and there's a parameter sheets. Again, that's what the team have believed that they're preventing this from happening. As far as the detection, there is the first article inspection. So every day at the beginning of the shift, They run through the first article and they inspect it to make sure it meets all the requirement. There's a visual inspection. Again, work instructions are also treated as detection. There is this 24/7. I think I don't know what KIC stands for, but I think it's Keyong. It's an inspection like visual inspection, automated inspection, where we're going to, because every one of those surface mount, the PCB boards go through that inspection automatically. So it's detected there. And the team identified, so since the RPN is only 18, team decided that no need to work on this. So there's no recommended action. And a couple of other things here similar to that. Again, as you see how it's flowing from left to right. And again, because of the RPN being 42, just because RPN is 42 doesn't mean that we're not, taking actions. Because we don't, best practice is that we don't use a threshold for RPN. We rank the whole process, FMEA, and with their RPNs from high to low, and it's part of the continuous improvement effort or the requirement in some of those international standards, either ISO 9001, IATF 16949. They seek for continuous improvement effort, and this is one of the ways we can show them that, hey, we did identify, even though the risk is not that high, but we still attack the high risk for the existing, within the risk assessment that we completed. Just because these are examples, like taken out of a full picture, so that's why there just happen to be no recommended actions. But if we think about it, if 42 is the highest RPN for the full FMEA, then we would definitely have some recommended actions to reduce that. And please keep in mind, maybe I'll even mention it later, but for the severity to go down, there must be a product or process design change. There's no other way that you can actually reduce the severity. So let's keep that in mind, please. Here are a couple of more examples. Again, so for example, the second one from the top, they actually come up with a recommended action, say add part number and traceability system. As you can see here, the severity was 4, occurrence 2, detection 1. Even though RPN was only 8, still they suggested that they want to add the part number and the traceability system to even reduce it further down. And this may be due to, again, certain customers may have specific requirements for certain processes. And this may be one of those where the customer wanted to make sure that even the risk was low, but it was totally eliminated. So some key points about PFMEA as this is to wrap it up. So conducting PFMEA timely is really important. You don't want to do it after you're in production. Quantifying risks using RPN, mitigating manufacturing process risk, and assume the product as designed will meet the design intent. Really, that's a very important step here, because we are not to fix the product flaws with the process. Because if we tend to do that, that defeats the purpose of overall APQP's goal, because APQP methodology begins with the design risk assessment, design record, design risk assessment. And the design FMEA is done to identify those risks and mitigate them during the phase 2 of APQP. When you're in phase 3, where you're developing the process, again, you're assuming that the product will meet its intended requirements, because otherwise it will take forever to complete the process. Risk assessment. The failure modes can relate to products, defects, non-conformances, or the processes. Effects can affect the operation, subsequent operations, customer operations, as well as the end customer. Occurrence cannot be reduced without changing the design or process to decrease the chance of failure cause and subsequent failure mode from happening. The FMEAs and the PFMEAs are, as I pointed out before, living documents and should be revisited and updated as new information and the results are obtained. Avoid overanalyzing or underanalyzing. So there should be this balance, because if you do it over, then it will take forever to complete it. But if you do it under, then you may miss some of the key risks. So again, you have to find that balance to be evaluated. Scope the FMEA correctly. So you need to make sure that you focus on the right processes. Make sure the lessons learned are used as input to PFMEA, as we captured that in this AIAG methodology. Make sure to modify process control plans after mitigation actions are implemented. As I was pointing out, you need to recalculate the severity, occurrence, and detection. So that needs to be actually documented in the process control plan as well. The FMEAs and the PFMEAs will be performed ideally with members who are common to both teams to facilitate the concurrent design build efforts. So the reason why we're stating this is because if you have a total 2 different teams focused on each of these risk assessment, the knowledge, right, is not going to carry with from one risk assessment to the next one. So the result is not going to be, as good as you expect, and plus, I think it will take even longer time to actually complete both assessment.